Okay, so now we get to the solar eclipse. Okay, the lunar eclipse is when the moon moves through the Earth's shadow. The solar eclipse is when the moon's shadow travels across the Earth. Now, since we're on the Earth, what it means when you're in that full shadow is it blocks out the sun. What happens with the moon, in this case, it's the shadow passes over the Earth. See, like that. But you notice that here, anybody, you're not going to really be able to see it very well unless you happen to be right under the shadow. Okay? So what does it look like when you're looking from the perspective of the Earth? It looks like the moon is blocking the sun. Okay? No, it doesn't. The lunar eclipse doesn't block out the moon because we're viewing it from the Earth, right? It's still, the sun isn't in the way. But if the moon gets in the way between the Earth and the sun, it can block it up. Now, as it turns out, now the moon is way smaller than the sun. Way smaller. But the sun is way further away. So the apparent size of the sun and the moon is almost exactly the same. You know what I mean? You know how when something goes, okay, look at the size of my hand. As it gets further away, it appears to be smaller and smaller and smaller and smaller. Well, the same thing with the sun, right? It's way bigger than the moon, but it's way further away. And as it worked out, they're just about exactly the same size. Let me see. Actually, I just thought of this. Let's see if I can get this to happen. Here's the moon and the Earth are about this. Now the sun is like, okay. As if they're just about the same size. And if that moon goes across the sun, it could block it out, right? And that's what happens during a solar eclipse. Now you can have a partial solar eclipse where it goes, let me get this, hang on. Okay. Yeah, partial solar eclipse where it goes over part of it, but doesn't block the whole thing. If a partial eclipse happens, I've seen like maybe 4 partial eclipses because I knew they were going to happen. If you don't know they're going to happen, you're not even going to notice it because what ends up happening is it gets a little dimmer, but people don't just walk down the road and go, oh, the sun is dimmer, because it happens all the time because clouds move in front of it. So we're used to it, right? Unless you're expecting it. Now, if you know it's going to happen and you get a partial solar eclipse, then you can kind of enjoy and go, oh, look at that. In fact, a couple of years ago, there was one right at the end of school. And so a few kids, we looked at it with special eye protection that they had. Okay. Now, that's one kind of eclipse, is a partial eclipse. Total eclipse is when it covers the entire, come on. It's not as easy as you think. It covers the entire thing. Oh, that's a total eclipse, right? Now, an annular eclipse, because the moon's orbit is not a perfect circle. It's a oval, right? So sometimes it's a little closer, sometimes it's a little further away. And so what happens if it's a little further away, the moon's apparent size, now that's kind of exaggerated. It's a little, if the moon isn't big enough to cover the whole sun, that's called an annular eclipse. Now, let me try to get that. Good. I'll show you a picture of one. It's just barely not big enough to cover it. That's an annular eclipse. Okay? And sometimes it's called the Ring of Fire is what it's called. This is kind of cool. Now, here's something else that's interesting about that annular eclipse thing as it gets further away. I mentioned before that the moon is actually getting a little further from the Earth every year, about 1.5 to 2 inches further away every year. In about 1 million years or so, you're going to be the last total solar eclipse because the moon's going to be so far away. It's going to be apparent size is going to be smaller than the sun, even when it's at its closest. And so there won't be any more total solar eclipses. So we're kind of lucky that we happen to live in the era of 4.6 billion years this planet's been the moon going around it. We got about another 1 million years to go before there's no more solar eclipses. Okay, so here comes the lesson. Solar eclipses is when the moon's shadow travels across the Earth, blocking the view of the sun from that spot. Now, these kind of pictures where it looks orange, the camera had a special lens on it that cuts the light quite a bit. And so that's how they get that. And then they turn the filter off so it looks more brilliant, and you can see the light a lot better. And that's what's called the sun's corona. It's in sense it's an atmosphere what's glowing, the corona of the sun. All right. Okay, so the thing about the total solar eclipse is it's very rare to see it, and it's very beautiful. Here's a nice picture there. This one here, I'm going to get to the solar eclipse that happened in the Pacific Northwest a couple of years ago in a few minutes. But I'm going to tell you, if you ever get a chance to see a solar eclipse, take the opportunity. I mean, I've been wanting to see a total solar eclipse for years. And finally, 2 years ago, I finally got a chance to see a total eclipse of the sun. I had to go down to Oregon to be there at the right spot. Went down to Salem, Oregon to see it. And it was definitely cool and worth it. So you guys, I hope sometime, if you didn't get a chance to see that one, I hope sometime you get a chance to see another one. And I'm going to explain why it's more rare than the lunar eclipse in just a few minutes. Okay. So it only happens at the new moon phase. So what happens then if the moon is going to block the sun from the earth? Now, of course, the scale of this to show it, there's the earth and there's the sun is like way smaller. It's exaggerated and stuff, but it shows the umbra, which is the area that is totally blocked by the moon, and then the penumbra, where it's partially blocked by the moon, right? If you were on the earth here, what you would see is part of the sun is blocked. That would be a partial eclipse is what you see when you're in the umbra of the solar eclipse. Okay? And now it happens to happen at the new moon phase because look at the position. The moon has to be on the same side of the earth as the sun, right? And that's new moon. Waxing crescent, first quarter. Waxing gibbous. Full moon is when it's opposite. New moon is when it's on the same side as the sun. All right? And so let's do kind of a diagram here, like we did before. Have your paper and pencil ready, and here we go. You got to get that narrow umbra. Okay, so I'm going to do the earth. And I think I'm going to draw the umbra first so I don't get my scale wrong, because it's pretty hard to just freehand draw this. So here's the shadow. The sun's over on this side here somewhere. And here's the shadow of the earth, sorry, this is the shadow of the moon. Here's the moon. It's on the same side of the earth as the sun. Here's the sun's over here. Now, the earth is bigger than the moon. And there's the umbra. Remember, umbrella covers it, right? So it's just a tiny spot. It's just, it's about 100 miles wide. That gets covered by the sun. Gets covered by the shadow of the moon. And now the penumbra, where the partial eclipse is, would be anywhere where there's light from the sun. It kind of can cover more of the earth. So if you're anywhere in the penumbra, the penumbra would be where you'd see a partial eclipse, okay? And the closer you are to the middle, the closer you are to the umbra, the more close to totality you get. The more of the sun appears to be blocked by the moon. Because here's okay, so I'm going to try to do this extension here. This is why I didn't want to do the sun until I did that. Anyway, it's anywhere the sun can shine, even if it's partly blocked, is the penumbra, okay? The umbra is the sun is completely blocked. All right, so this is going to happen during a new moon phase. I messed it up. New moon. Okay, and there you go. That would be a solar eclipse. And so people that are in this region of the earth are going to see a partial eclipse. It's only in that tiny little spot that you're going to see the total eclipse. That's why it's more rare that you're going to see it. You have to go exactly in the right spot, exactly at the right time. Because not only do you have to be in the exact right spot, you got to be there at the exact right time too. Because what's happening is as the shadow is shining, or shining if the shadow shines, the shadow is being cast upon the earth. It's also the earth is spinning. And so, yeah, the moon slowly goes around just like a lunar eclipse, but a lunar eclipse lasts a lot longer because what's happening is the Earth is spinning through that shadow. And so what happens then is the shadow travels across the Earth uh, pretty fast. And so you got about, at the most, 7 minutes maximum. Usually, depending on where you are, it's like 2.5, 3 minutes you got. Okay, depending on how close you are to the absolute perfect spot. Okay, so it doesn't last very long. It goes really quick, and you got to be in exactly the right spot to see it. So it's a lot more rare to see. They do still happen about twice a year. You got that ascending node and descending node action going on, where it doesn't happen most of the time because, okay, here's the Earth and here's the moon. Most of the time, okay, it goes over, right? Or it might go under. So, because it's a slightly tilt compared to the plane of the ecliptic of the sun and the Earth. It's only when it goes perfectly right between that you're going to have that eclipse, okay? And so it does happen in some variety about twice a year. It could be a partial eclipse. It could be a annular eclipse. So it does happen. Only happens during the new moon, but it does happen about twice a year. But it has to be exactly in the right spot, whether 2 times there. But you got to be in the right spot to see it. Okay, but it only can seen from a small part of the Earth. Okay, this diagram here, what this shows, I love these diagrams. This shows the path of the eclipse, and this red spot is the best part. So unless you happen to be right in the middle of the Pacific Ocean over here around the Marianas Trench or somewhere, you're not going to see the best part. Now, you might see part of it if you were living in this region over here. That's through China and stuff. Okay, so it gets things by. Now, what these lines are is this, everyone represents like 20%. Here you'd see 80% of the sun is blocked out. So it definitely, if you were like in a boat there, you might be fishing, you say, the sun gets 80% blocked, you might notice it, or you might not, because it'd be like I said, it's like a cloud goes over the sun all the time. We don't go, oh, it got dimmer, because we're used to it, because clouds go over. So you might not even notice it. But if you're in that special place, totality only lasts about 7 minutes maximum. Most of the time, it's like about 2.5 minutes the time I saw it. Okay, and look what happens. Is it blocks the brightest part of the sun, and what's left is the corona. It's what it's called, okay? The glowing atmosphere of the sun. And that is something to behold. It's very, very cool. So I recommend, if you get a chance to see a total eclipse of the sun, take the opportunity. Okay, so here's a series of pictures that were taken, as the day went on. Somebody took a picture. Here's the position of the sun as the Earth rotates, right? And the moon moves across there. Here's blocking part of it. Here's blocking more. This is about a 90% blockage. Here's totality. Okay, here's another picture of the same type, where here the sun is rising as it's going into the eclipse. So it's rising and the Earth is spinning this viewer through that shadow as the sun rises into the sky. And here's totality, and here's where it gets out of the penumbra. Again, this is that moment. Sometimes it's called the diamond ring. This is the moment that the sun vanishes. And then I mentioned before, this is what's called an annular eclipse. This is the one where the moon is so far away, it can't quite cover the entire sun. And so you get this red ring around there, okay? So that would be kind of cool to see. I've never seen one of those. It would be pretty awesome.